Hey guys, this is 7.2 binomial distribution. There are certain things about the binomial distribution. Have these four things in common all the time. These are the features of a binomial experiment. Number one, there are a fixed number of trials. Okay. Means we do this 20 times or we do it 12 times. It's a fixed number. Each trial has two possible outcomes, either yes or no, heads or tails, something like that. The trials are independent. So just back to like the basic stats, they don't, one trial has the same probability as the next one. They don't have an effect on each other. The probability of each outcome is constant throughout the trials. Things do not change from time to time. Okay, this comes from the binomial theorem, a lot of what we're using. And this right here is called, when we didn't have the expansions, was based on the Pascal's triangle. So what you've got here is just the numbers out front, the coefficients. You start out with 3 ones. Always start with a 1, then you add up the 2 in front of it. 1, 2, 1. Start out with a 1, 3, 3, 1, 1, 4, 6, 4, 1. And then 1, 5, 10, 10, 5, 1. And that is your x plus y to the 5th. These type of things are how we are going to expand on the binomial distribution and get our probabilities. This is where it's coming from. Okay? This might be out of order. No, it's not. The formula for the binomial theorem can be written as this n factorial over r factorial n minus r factorial. That right there is going to be very important. All right, expand the following binomial using Pascal's triangle, x plus y to the 6th. Okay, so the 6th term down here, which we would be adding together, is 1, 6, 15, 20, 15, 6, and 1. These are the coefficients out front. Okay? So, I've got 1, 6, 15, 20, 15, 6, and 1. And the x's and y's that go with it are starting at a 6, the y would be at 0, plus the x goes down to 5, y goes up to 1, x goes down to 4, y is 2. Notice how these add up to 6. 20 is 3, and y is at 3. 15x squared, y to the 4th. And notice it's symmetrical. 15x to the 4th, y squared. 15x squared, y to the 4th. x, 1, y to the 5th. And then you have x to the 0, y to the 6th. So these things right here it's all about the Pascal's triangle and expanding the binomial. And it will be used for what we're doing. Okay? Right here. Managers at the Eco Landscaping Company know that a mahogany tree they plant has a survival rate of 90% if cared for properly. If 5 trees are planted in the last phase of a landscaping project, what is the probability that exactly 4 of the trees will survive? So what we're looking for here is the probability that the tree will survive is 90%. The probability that it will not survive is 10%, 0.1. Okay, we'll call that Q. All right, now, expanding this out, we have 5 trees, and the probability that it will is 0.9, and there are 4 of them we want to survive, and 1 we don't want to survive. Well, we don't want it, in the problem it doesn't survive, not that we don't want it to. Okay, so on here we've got 4, 1 right there. That x plus 1 to the 5th, x plus y to the 5th. And we've got probability it survives, probability doesn't, and a 5 out front. Okay, that's what we've actually got here. It's the 5 out front, 0.9 to the 4th, and 0.1 to the 1st. So, I'll multiply that out real fast. 0.9 to the 4th is 0.6561 times the 0.1 times the 5. And you get 0.3281. It was 805. 4 decimal places is pretty good. But that's the probability that exactly 4 trees will survive. Okay, so there's the probability that exactly 4 will survive. And notice that the beginning number, 5, we got as a combination of 5 things taken 4 at a time. Combination of 5, 4 is 5 over 4. 5 minus 4 plus 1 gives you that. And that leaves us with 5. This gives us the binomial probability formula, okay, is n combination x, probability of it happening, yes, to the number of times, to the number of trials, the ones you want out of the number of trials. And q n minus x means these two numbers add up to the total. So we would have written the previous problem as the combination of 4, 5, times 0.90, which is the probability it would survive, to the 4th, and 0.1 to the 1st. 4 plus 1 equals 5, which is what we did. Okay. As part of a promotion, a store is giving away scratch-off cards. Each card has a 40% chance of awarding a prize. Suppose you have 5 cards. Find the probability exactly 4 of the 5 cards will reveal a prize. Okay? So this is pretty much like what we just did, except for the chances. You have a yes or no, it will have a prize, or it won't have a prize, win or not. Probability of success is constant, 0.4 throughout the trials, and they are independent. One card does not affect the other. So here we go. You've got 5 combination 4, the probability of winning, which is 0.4, probability of losing, which is 0.6. 4 plus 1 is 5. So you end up with 5 times this times the 0.6, and it comes out to about 0.08. Okay? What is the probability that the number of cards that reveal a prize is 0, 1, 2, 3, or 5? Well, this brings in your situation where we have, adding a table here, a probability distribution. Okay, we've got 1, 2, 3, 4, 5. Okay. Whoops. Not sure why it's not moving on me. But, well, I'll just draw where it is. We've got the probability. They want a 0, 1, well, I'll write it out here. 0, 1, 2, 3, 5. So these are the other ones beyond the 4. 1, 2, 3, and 5. All right, that's your number, your x. And then you want the probability of x. Well, for the 0, you would have 0 out of 5 times your probability of success, which is 0.4, 0 of them. Probability of failure, which was 0.6, all 5. For the next one, number 1, you get 1 out of 5. Probability of success, 1 chance. Probability of failure, 4 of them. 2 out of 5. Success, 0.4, you get 2. Failure, 0.6, you get 3. 3 out of the 5 winners. 0.4 chance, 3. 0.6, 2. 3 plus 2 is 5, just like it does all the way down. And the last one, all 5 are winners. 0.4 to the 5, and then 0.6 to the 0. Okay. So what we've got here is, let's see if I can get my, nope, it's gone. I forgot I had a new computer. So I'll just get my basic calculator here. See if it does it. Nope. Okay. Okay. Combination of 5, 0 is back to where we had before. I can't get back to that slide. Back to where we had before, it is 5 over 5 and 0, just like we have here, which is equal to 1. 0.4 to the 0 is also 1. And then 0.6 to the 5th, you have 0.07776. 0778, if we want to round it off. Then this is 5. 5 combination 1 is 5 times 0.4 times 0.6 to the 4th. And we'll get numbers for each of these that will go right in here to the probability. So when I come back, it'll be all filled in. I'm going to call it quits on this video. We'll pick up in the second one.